Today will be our first tutorial on Chapter 6, Vector Calculus. Chapter 6 is your last chapter in this course, so we'll start now with an introduction. Vectors. Vectors represent certain values in physics or mathematics. Okay. Uh, some of the famous vectors, like you can see forces. There's weight, which is also gravitational force. Attraction, contraction, any of these can have a vector quantity. Vectors are usually indicated in the following form. Let's say a force can be given in a form of a vector. So it can be indicated with this arrow in above the letter. Okay, this chapter actually, or this part of the chapter is related to chapter 2, complex algebra, where you can also discuss the new type or the more familiar type of vectors, which is the Cartesian vectors. And there's a slight introduction. Well, it's not going to be included in our final about spherical and cylindrical coordinates. So we'll start with operations on Cartesian vectors. We'll start with addition, finding the addition and subtraction of a vector. Let's say you have a vector A plus vector B. This will be equal to, since A and B are both vectors, A will have, let's say, X I hat plus Y J hat plus Z K hat. As for B, you'll have U I hat plus V J hat plus W K hat. By finding this the summation of these two vectors, you can just basically find a summation of these values, the corresponding values from the same coordinate. So this will give you X plus U I hat plus Y plus V J hat plus Z plus W K hat. Okay, this is how you find the summation. As for subtraction, see, in summation the order will not matter. So if you use U plus X, V plus Y, W plus Z, you will still have the same values. But if you have subtraction, A minus B, you will get, you must start with an A, then subtract B. You cannot do the reverse, because this will give you a wrong value. This will give you actually a negative value of the actual, or you can say an opposite direction value of the actual vector. So let's say if you have a vector that's going this way, summation, let's say it's going this way. When you have the wrong value, you might go to the other side, like below the plane that you're working on. So this, you can say that A plus B is equal to B plus A. As for the negative, A minus B is not equal to B minus A. Okay. So let's have an example on this, an actual example. Let's say you're given the vectors R. I don't want to use R to not get confused with cylindrical and spherical. Let's say P, 4I plus 3J plus 0K. And as for Q, you'll get 0I plus 2J plus 4K. You have P plus Q. You just find the summation. This will give you 4 plus 0 I hat plus 3 plus 2 j hat plus 0 plus 4 k hat. This would be a 4 I hat plus 5 j hat plus 4 k hat. Okay. Now to get the subtraction, you do the same thing, but with, of course, with a minus sign. This will give you 4 minus 0 I hat plus 3 minus 2 j hat plus 0 minus 4 k hat. So be equal to 4 I hat plus 3 minus 2 is 1j hat, and there's negative 4k hat. Okay, what's the use of subtraction, addition as subtraction? Previously, before when we studied vectors back in physics and calculus, we didn't use these methods. We used the slightly different ones where we just found, actually, they're not different, they're sort of related, but now you can understand the relation. When you're going to find the forces and such system, you need to find the components, then find the summation of these components. Then finally you get by finding the summation f of x squared plus finding the magnitude. Okay, these three steps can actually be, you can say it can be solved into two simpler steps, where you're going to find analyze the forces and so on. This can be found easily in the following steps. Let's say this is an example of mine. You're having forces. Okay, this is the x and y plane, x, y. You're having a system, and it is having this force and that force and this force. Say that's W, P, theta, and Q. Say this alpha. Okay. Let's indicate that W is equal to mgj to the negative direction. Okay. Let's say that the m is equal to 1 and g is 9.81, as we all know. This will give you the following 981 j hat. Okay, to find the total force acting on this object, and instead of going to use Fy and Fx, or you can say the components or the forces components, you can just easily do this. Okay, P plus Q. In our case, since we have a W, you need to do P plus Q plus W. In this case, we will have this, the same for P plus Q. Then you need to subtract this value. Let's have it 4I plus 5 minus 9.81 plus, yeah, sorry, plus 4K. This will give you 4I hat minus 4.81 J hat plus 4K. To find the total force, you can just do a simple magnitude, finding the magnitude, plus 4 plus 81 square plus 4 square. This will give you the magnitude of the force. Okay, now here we studied, or you can say understood, with an example of two of the famous operations in vector calculus, where we found the addition and subtraction, understood how we can actually use this in our system, And we also understood the magnitude of a vector. Magnitude of a vector, of course, we all know this from Calculus 2 for engineers and Physics 1 and maybe other courses. Okay, let's go to unit vectors. A unit vector is a vector that has the magnitude of 1. When you have a vector that has a magnitude of 1, this means that this is called a unit vector. Okay? To have the unit vector, let's say we have the vector A divided on its magnitude. This will give you the unit vector of A. Okay? Let's say we have a vector of value 3i plus 4k plus 2k. Sorry, this is a j. Okay. To find the value of this, we can do the following: 3i plus 4j plus 2k over the magnitude of this vector. So 3 squared plus 4 squared plus 4, which is 2 squared. This will give you 3i plus 4j plus 2k over 3 squared is 9 plus 16 plus 4. So it's going to be 20 square root of 29. This will be the square root of 29. This can be simplified to 3 over square root of 29. If you can actually simplify this, you can go for it. It's fine. But you'll not get any difficult values in the exam. 29 j plus 2 over square root of 29 k. This is a plus sign. Now, if you actually found the magnitude of this vector, you will get the value of 1. Okay? If you found the magnitude of this vector, okay, you will get the value of 1. You can try that, okay? You can try that. I will not do it, so you won't get confused, but you can try that and you'll get the magnitude of 1. Okay, now number 4 on operations topic, we get multiplication. We have multiplication for a dot product and for a cross product. Both have applications in our system or our calculations. Actually, here sine theta, I'm not sure about this term here. I don't trust this term, but you can work on this. It's fine. This one is correct. Okay, this one is correct. As for this, not really. I don't advise you to do work on this, but yet we'll understand what cross product is. Okay. Let's start with multiplication. Multiplication. Let's start with the dot product. Okay, dot product, the easier one. Both are easy, but this one is easier. So when you have two vectors, let's say, again, the same example, xi hat plus j hat plus zk hat, and for b, u I hat plus v j hat plus wk hat. To find the dot product, you need to do multiplication of just the values here. Okay. Okay, just simple multiplication. So this will give you, actually the result here will be scalar value, not a vector. Vector, remember the vector that has the components I, j, and k. A scalar is just a function or just a number, just a constant. It can be either a function or a constant. Remember this, don't do this misconception. Okay, So the result for A dot B is equal to XU plus UV plus ZW. Okay, this is how it gets solved. Okay, let's do an actual example on this, but this time I won't use constants. I will use some variables in our calculations, or we can say functions. Again, this you can do this also on previous set in the previous examples in subtraction and summation. You can also get other functions, okay, in the vector. To do this now, the same a dot b. Let's say a is equal to 3x I plus 3y square j plus 2z cubed k. And there's b 4x square I hat y j hat minus 4z k hat. Okay, to find the product of both vectors, just multiply the corresponding values from the other vectors. Okay, with the sign, do not forget the signs. This will give you, since 3x multiply the 3x squared, sorry, this is 4x squared, 4x squared plus 3y squared multiplied with y plus 2z cubed multiplied with negative 4z. This will be equal to 3 times 4 is 12, x times x squared is x cubed, plus 3y cubed, plus, here minus 8z to the power 4. Okay, can do any example on this. Also another note on dot product, that a dot b is equal to b dot a. Okay, these terms are equal, so you can start with the b, then you'll get the same answer. Okay, as for cross product, let's go with the same functions that I got earlier. It's horrible. Okay, cross product with same equations that we work on, or the same vectors. Cross product can actually be done for 2D and 3D, but I will teach you how to only use the 3D method to also to get the 2D or the 2D and 3D. And instead of learning two methods, we can go with one. Okay. As for A and B, let's just keep this aside. Or no, just keep it, I'll leave it for the end. Okay, so A cross B can be given as the following. You need to do a matrix A, J, K. Okay, this is a 3 by 3 matrix. 3 rows with 3 columns. Okay, horrible handwriting. Anyway, Now you need to plug the values according to the order that is given. So A cross B, this means that A is going to be first and B second. So A is going to have X, Y, Z. As for B, U, V, W. Okay, then now you need to write the components here. I, J, negative J actually, and K. As for the I, you can either do this, cancel the negative, put it here. See, it's fine. Just do whatever you want. Just get the correct answer. To start with, to get the I component, you need to cross this and work on these. Okay, so you need to work on these in this way. Y multiplied with W minus Z multiplied with V. This actually is called the determinant of a matrix. Okay. Now to get the J values, you need to cross first row and the middle column, and you'll get this XW minus ZU. Okay, this will be equal to minus XW plus ZU. Okay. I hat, J hat. As for K, the same thing. You need to cross the K with the K column and the first row. This will need just a simple cross multiplication or finding a smaller determinant. This will give you XV minus U, sorry, ASYU. Okay, this is the K component. So the cross product for A and B is equal to UW minus ZV I hat minus XW minus ZU J hat plus XV minus UY or U, whatever, K hat. Okay, this is how you can solve this. Now, to have an actual example on this, I'll solve two examples for this. We'll get this get the previous example before. Okay. Okay, we need to do the same matrix for A cross B. Okay. I, J, and K. I, J, and K. Remember this. We'll start with the A because A is the first or the beginning of the equation. 3x, 3y squared, and 2z. As for this, 4x squared, y negative 4z. To solve the I component, cancel this, you'll get this. So get 3y squared multiplied with negative 4z minus 2z multiplied with y. This is equal to negative 12 zy squared minus 2zy I hat. As for J, 3x multiplied with negative 4z minus 2z multiplied with 4x squared. This is equal to negative 12 zx minus minus 8 zx squared. Again, this will be simplified to 12zx plus 8zx squared all j hat. Okay. As for k, personally, actually, I put my finger on the paper when I do the calculations. I just place my finger on the top of the column that I want to find the components of. Now to cross the k, 3xy minus 12y squared x squared. I just skipped the calculation, supposedly that you know this. Okay, finally, A cross B can be determined by finding the summation of these values or these functions or these components. Okay, there's no simplification. You finally simplified everything. There's no any further simplification required. Okay, so just place these next to each other with the summation sign, and you're already done. Okay. Now, something I forgot about before. I'm not sure if you're going to get this in the exam, but just you know it. If you're required to find the angle between two vectors, let's say you have the vector A and B. Okay, and vector A, let's say this has this type of a vector, and B this has this. You need to find the angle between them both. To do that, there is a method, and it's very easy, so you don't have to worry about. First, you need to find, so let's say if you want to find the angle between A and B, you need to find the magnitude of vector A and magnitude of vector B. So the magnitude of vector A is equal to 9x squared, doing the multiplication, or you can say the power directly. Get 9, yeah, okay, 9y to the power 4 plus 4z to the power 6. Okay. Okay, this is very complicated. You won't get this. But okay, I will use a different function or different vector. Sorry for that. Let's say you have these vectors, but instead of having x and y, okay, you'll not get any y and x. You'll just get simple numbers in the exam for this specific type of question. So the magnitude of A is equal to 3 squared, 3 squared, 2 squared. This is equal to 9 plus 9 plus 4. This is equal to 18 negative square root of 22. As for B, you'll get square root of 4 squared plus 3 squared plus 4 squared. This will give you square root of 16 plus 9 plus 16. 32 plus 9 is 41. Okay, these are the magnitudes of A and B. Now you need to apply this equation or this equivalency. A dot B plus the multiplication of the both magnitudes with the cosine theta, or simply this one. Okay, so you do this cosine inverse. It's actually equal to theta Okay, remember this equation, please. You will start with the dot products. So the dot product of A and B. I need to find a new one because what we have here has an X and a Y value in. We can actually just ignore these since we have the same constants. So the dot product of A and B, since we ignored the constants for now, for this another equation or another question. So 12 plus 3 minus 8, this is equal to 17. Okay, the cross product of these two vectors and these two new vectors, these are for different question. Remember this. The cross product of these two new vectors is just 17. So cosine inverse is 17 over the multiplication of square root of 22 and square root of 41. Okay, now you need to find this using a calculator, but since we're not allowed to use a calculator, I believe this is enough. Unless if you're given the values, substitute. Okay, remember these, the stuff that I told you about cross multiplication and dot product and addition and subtraction. Now, this is not part of your curriculum, projection and computing magnitude, but yes. This is actually a solved problem or solved sample for you to work on. Please do it. Please try solving it. You see, it's an easy question. Okay. Now, going to other properties, other equivalencies. Yes, we will stop here to exactly stop here in this page. Okay, just remind me. The differentiation of vectors. How to differentiate a vector. How to do that. That's actually really easy. When you're having a vector, remember when I told you about having a vector or a scalar, it doesn't have to only have some constants in it. It can also have functions like I just gave you earlier. So let's say that you have a vector that's also has a functions for the same variable. Let's say you have the vector A that has 3t I hat plus 4t squared j hat and minus 2 square root of t k hat. And you are required to find the derivative to the respective time for this vector. Simply, you need to find the derivative for each and every component of the vector. Okay, so this means you'll get d dt. This is actually how it's written, but you could just proceed with solving plus d dt for t squared plus, we can say minus, since negative 2 is just a constant, you can just remove it from the calculations. I hat, j hat, negative 2, d dt, square root of t k hat. Okay, this is equal to 3 I hat plus 8t j hat minus 2, and the derivative of this is 2 square root of t k hat. This can be simplified to following minus square root of t k hat. Okay, that's the derivative of a vector. Now these are just other properties to have in a vector. These, you can just remember this. If alpha was a constant, let's say that you have the derivation of d dt of alpha, or not alpha, let's say 3a, okay? The same a that we have here. You can see that you can take the 3 out, do the derivation of a, which is this, will give you, which is this, just transfer it here, and multiply it with 3. This means that 3 is independent and does not have any effect on the derivation. Okay, but let's say that you have 3t a vector and you're required to find d dt for this equation. You have a function multiplied with your vector, and how to do that? Now you can do what's called the chain rule, which you studied before in maybe 3 courses, including this one, which can be performed as following: d dt 3t. Just let me make sure. Yes, multiplied, or just multiplied out here. This means that it's not related to the derivation, plus d dt, the vector a, and here you have a 3t. Okay, to get this, you'll get the vector a itself. I don't want to rewrite it, but you can apply it. It's here again. This is the new. This actually no. This is vector a. Sorry. Even this is wrong here. This is not vector a. This is the derivation of vector a. Vector a is all up here. This is vector a. Okay. Sorry for that. Okay. Just to clarify what I did. This is vector a. This is the vector d a over dt. To do this equivalency, 3 multiplied with dA dt, okay? As for this, no, it's not the same. We'll get vector A stays the same, the original one. 3t I hat plus 4t squared j hat minus negative 2t, negative 2 square root of t. d dt of 3t is equal to 3 plus 3t remains because it's outside. And d dt A is just basically this. Okay. I'll expand this for you. I think that you got lost. Sorry, that's my bad. Just a bit sick. Okay. Okay, sorry for that, but I believe that's the best solution. Um, I'll rewrite it. I'm sorry for that. 3t I hat plus 4t square j hat negative 2 square root of t k hat. This will have the following solution eventually with 3t, 3 multiplied with 3, that's 9t I hat, 3 multiplied with 4t square, that's 12t square, j hat, negative 6 square root of t, k hat, plus 9, this one, 9t I hat, 24 t squared, j hat, minus 3t over square root of t k hat. Okay. Now just find the summation of these. Sorry. You have these components or similar components. So 9t plus 9t, this will give you 18t I hat. This one, 12t squared plus 24t squared j. Remember, we're working on this. This is where we are going to do the summation accordingly. So 12t plus 24, this is 36t squared j hat. Finally, the k hat stuff, you'll get 6 square root of t minus 3t over square root of t k hat. Now try to simplify this. Try to simplify this as much as you can. I don't think there's further simplification unless for this one. You can simplify this furthermore if you want to. But I want you this time to discover it on your own for this part of the equation. It must have the same final answer that you have. What I mean is that you must get 3t inside the actual vector A. 3t I hat plus 4t squared j hat minus 2 square root of t k hat. Get this inside. This will give you 9t squared plus 12t to the power 3 negative negative 6t square root of t, or another way to solve it, t half. This will give you t to the power 3 over 2. Okay, and just rewrite it if you want to. T 3 over 2. Now just find the derivation of this. The derivation of this, and I want you to compare it to your final answer here. Okay. If you don't know how to simplify this, I can simplify it for you. This is negative 6 square root of t, negative 3 t multiplied with t negative half. This will give you square root of t, t to the power half, or square root of t. Again, k hat, this will give you negative 9 square root of t, k hat. Okay, just to rewrite, sorry, I'm doing it in a messy way, but I don't see any other way to do this. Plus 36 t squared minus 9 square root of t k hat j hat here. Sorry for that. Okay, now I want you to find the derivation of this term, okay, the respective time, and compare it with this. These two must have the same answer. This will show you that this equivalency is true, or this is the proof of this equivalency. Okay, I can see that there's no one here in the meeting. Okay, there's Marian. Okay, I want you to solve this by your own. Try solving this again. You can see that this, in this case, it's simpler to use the first type of equivalency, which is this. Maybe in other cases, you might find this one easier, maybe in far more complicated questions. Okay. As for dot product, As for dot product, you get the same idea, but personally, I recommend you just finding a normal dot product, then differentiate to the respective the variable you're asked. The same thing applies on cross product. You can see here they're all similar because both or the three of them has the same core concept, which is the chain rule. Okay, again, I suggest that you solve it normally. Just find the cross or dot product required, then differentiate at the respective time. As for this, depending on your choice and depending on your experience by solving questions, sometimes one of them can be easier. Okay, this is a solved example for you. I think that you have this PDF. Try solving this by your own. If you couldn't, just review the manual. Okay, now introduction to gradient vector of a function. Okay, that's interesting. Let's say that you have a certain function of any values, mostly x, y, and z, and you want to represent this function in 3D space. Okay, you need to represent this function as a vector or transfer this function into a vector. Again, a vector can consist of variables. A vector can consist of functions in it. Sorry. Now, to represent a vector in 3D space, you're going to be introduced to this concept, which is called the gradient. The gradient function or the gradient vector. The gradient vector is mainly partial with partial x I hat plus partial over partial y j hat plus partial over partial z k hat. Okay, this is the gradient vector. Now you're going to learn to operate on finding the gradient vector of a function, or what's called the directional derivative. You can see, you can study it as a vector or a normal function, or even the newest, or not the new, a new different type, which is called the Laplacian. The Laplacian is related to heat transfer, actually, and curl is related to fluid mechanics, all having the value or the valuable concepts of curl and divergence, and all are related to the gradient vector. Okay, let's work on finding the gradient of a vector A that has the values of, or not actually not vector, a function A this time, starting with function A, which is a function of x, y, and z, which is 4x square y square root of z. Okay, this is a weird twisted up function. Just change it and find the gradient of this vector. To find the gradient of a vector, you can say, you can represent it as the following: gradient vector with a subscript a or the function, or gradient multiplied with a. Both are the same thing. In other textbooks, you can find them in the following. All are the same, as long as you're solving correctly, hopefully. To apply this is our gradient vector. We're going to use it and multiply it with our function a. 4x squared y square root of z. Now we need to multiply this here, there, and here. This will give you partial over partial x, 4x squared y square root of z I hat plus partial of a partial y for x squared y square root of z j hat. Finally, partial of a partial z for x squared y square root of z k hat. Now to solve this, partial of a partial x, this means that you're going to differentiate to the respect of x. Everything else is a constant now. This will give you 8xy square root of z I hat plus, as for this one here, y is our variable, everything else is a constant. This will give you 4x squared square root of z j hat plus, sorry, 4x squared y over 2 square root of z. Remember that the derivation of a square root function is equal to, okay, actually this one is f prime, and not f of x, maybe f of any variable, it doesn't matter. So this, in our case, you get f prime of the inside of the root is just 1, 2 square root of the actual root, which is z. You can see we just did the same thing here. Simplify this if you can. As for here, we can have just a simple simplification just by canceling these two and writing a 2 here. To rewrite it, I don't want to rewrite it, I'm too lazy for that. Just do this. Okay, that's the gradient of function a. Now let's say that a is a vector. A is a normal vector, just a vector, not a normal vector, sorry, just a vector. Let's say 4x y I hat plus 3xz y j hat plus 4z square k hat. Find the gradient. Again, the same thing. I don't want to rewrite this again, but just let's do it. Partial of a partial x for this is for y I hat. Actually, there's no I hat here because this is a dot product. And for this partial of a partial y, going to be 3x z. And for this one, partial z is 8z. Okay, this is the gradient of this vector. Okay. This equation measures the net flow of a fluid. Net flow equals inside flow minus outside flow. I don't know how to do this, just memorize it, I think. Now, the higher order, or what's called the Laplacian of a vector, or it can be for a function, it's fine. To find the Laplacian, Laplacian is basically multiplied with this double. Okay, you'll start with this first, which is this, then apply the Laplacian again. Okay, but this time the Laplacian will have the components. Okay, I think there's a mistake in my summary. I believe that I think yes, you must get the components. So we'll just jump into it here. 4y. What's the partial x for 4y? It's 0. I hat. As for this one, partial y for this is 0 j hat. And partial z for 8z is equal to 8 k hat. Just to write this here. This is called the Laplacian of a vector. Now we understood two concepts in one question. Now I want you to remember these the divergence. Divergence is just the dot product. As for the new topic, which is curl, is called the cross product. Okay. Make sure of something here. Okay, good. The cross product of a vector. Cross product of a gradient, the gradient here, cross product with a function. This gives you what's called curl. Curl is the measure of a rotation of a flow. This can be applied in fluid mechanics, specifically chapter 4, kinematics. Kinematics of fluids or fluid kinematics, where we measure the vorticity of a flow and the angular velocity of a flow. In fluid mechanics, we took this is equal to curl, and this one is equal to half of the vorticity. That's square, there's no square. Half of the vorticity, hence half of the curl. For people who took fluid mechanics before this course. So for you to relate. Now, let's say that we have the vector of, I want to use the same vector here. Hmm. That's so inconvenient. Okay, let's find the curl for this problem. Curl is equal to the gradient cross A equal. Again, remember, we're going to do a cross product. So we're going to use the matrix, or you can use the other methods that you learned from previous courses, but personally, I prefer this. This one's much easier. And K here. Okay, now remember, we're going to start with this. So partial over partial x, partial over partial y, partial over partial z. And we're going to write this for xy, 3xzy, I guess, yeah, and for z squared. Now we're going to find each component. Remember, if we're going to start with an I, just cross these and find the determinant of the smaller matrix. So get 4z, or actually partial over partial y, 4z squared minus partial over partial z, 3x zy. This is equal to partial y for this is equal to 0. As for this partial over partial z for this is just 3xy. So this is 3xy I hat. As for j, cross these, and you get these two columns, treat them as a one matrix. Partial over partial x for z squared minus partial over partial z for xy. This is equal to partial over partial x for 4z squared is equal to 0. Partial over partial z for 4xy is also equal to 0. This is equal to 0, j. As for k, you'll get partial over partial x, 3xzy minus partial over partial y, 4xy. This is equal to partial of a partial x for 3xzy is equal to 3zy minus partial y of a partial x, sorry, partial of a partial y for 4xy is equal to 4y. Okay. 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 Now that's the curl for this function or for this flow. Rewrite it again. Curl cross product 3x y I plus 3 zy minus 4y k hat. Okay, now that's the curl for this flow or for this vector. Now let's understand this relation from fluid mechanics. Now whenever you find the value of the curl of a certain vector, and you got, let's say you got these three possibilities, whatever possibilities, okay? 0, positive, and negative. Whenever you have the curl in a negative value, usually it's a constant, by the way. I'm speaking in if it's a constant. Or whenever if you're giving the values of x and y, certain constants, let's say x is equal to 4 and so on, and you're required to check this now. Whenever you have 0, this means that you have an irrotational flow. Okay, the flow does not turn. This means that flow is just going in a straight path. Okay, or this way, not together, of course, only or. Okay, remember this, or this way. Okay. Okay, whenever you have the flow or the curl in a negative, this means that this flow is making a vortex. Okay, making a vortex, but this one is going with clockwise direction. Okay. Now, if you have a positive curl, this means that you're going to make a vortex with a counterclockwise direction. This one is shown here in these applications. These are actually the 6 examples that you're going to deal with in this course. I want you to remember these and understand them, and if you want to, you can apply the concepts that you understood from divergence. And I want you to understand, sorry, where is it? Yes, I want you to apply the divergence and the curl for each of these flows. I gave you the values of these. I want you to apply curl and divergence, and you must get similar answers. The same answers, actually. This will give you the understanding of what you're doing here. Then after doing that, you can understand these concepts, then eventually memorize them. See, I don't like memorizing, but if you understood this, you can memorize them by understanding. These will be a big part in your exam, and you might have at least 1 page of this. Okay, at least one full page of this, like around 15 marks of your total grade will be related to this page. Okay, check for other sources if you want to. I want you to read this, try to imagine it, and apply curl and other concepts and divergence to show you and make you understand what you're doing here. Remember, remember the counterclockwise and clockwise flow. Remember the signs. Remember these. You can see both have similar looking flow, but both are not the same because there's an inlet, outlet having different speeds, different flow. Here we're having the same flow, just with a different vector. I want you to remember this. You will get this as an MCQ, and I got them. And unfortunately, I didn't do well because I didn't study this. Uh, as for vector field of a function, I'm not sure what is this. Okay, we studied them and we did nothing. Spherical and cylindrical coordinates, luckily, you don't have them in your syllabus, or at least for this semester. So you can say that you avoided them. The next tutorial, we will have line integration. And for polar functions, the same thing. We're going to solve some examples and uh, proving line integration with Green's theorem. Again, we'll also do the Cartesian and polar integration. Finally, we'll reach to divergence, 2D and 3D, then Stokes theorem. Okay, you can say that this is most of our work, and after these 2 or 3 tutorials, uh, our material is done. So I just want you to review what I showed you here in the recording. Please also review the summary. There are solved questions. I showed them to you, and review the flow rate questions or the flow questions. Please, I'm emphasizing on this because I messed up in the exam in this specific topic. I don't want you to do the same. Okay, anything else, guys? Do you want me to explain anything else? Hello?